Okay, so in the last video we saw that we had an issue when dealing with our twist angle for matching our attach and detach shoulder controls. So let's see what that issue is again here. We can see if we grab our attach control and we're to rotate it through one complete revolution, so just over 360 degrees, and then say match the detach to attach. Take a look at our orientation for the detach and orientation for the attach, and they're identical. However, if we blend, look what happens to our twist angle. Our twist angles are not the same, and that makes sense because what we're doing currently is we're asking to match the orientation of our controls, and it will do that without having any concern for whether or not we've gone through a complete revolution and whether or not we are going in one direction to get to that angle or another direction. It simply matches the orientation in the quickest way that it can possible. What we need to do, we need to find some way of getting both our twist angle and also our control RX, because that's based on rotational parameters as well. We need to find some way of getting those matched when we match our attach to detach and vice versa. So what I'm going to do, I'm going to create some offset parameters. And we can think about this as, let's look at where we need to be with that twist angle, and we can see that by blending over to the target, whether that be attach or detach based on which we're matching. We can take a look at what the twist angle is on the target currently, and we can take a look at what the twist angle is on us after we've done that orientation and position match, and then we can work out what the difference is there, and we can use an offset parameter in order to create that difference that's needed. And if we take that into account on the actual twist angle and control RX parameters themselves, that means we can now offset those parameters by a value in order to match the correct twist angle. So it means we are going to have a couple of extra parameters that the animator, if they want to, can work with. Really, they're intended to be worked with by the script, but they're provided for the animator in case the animator needs to go in and make modifications in terms of keyframes, etc. It's worth noting we are going to be appending into that offset parameter as opposed to simply replacing the parameter each time, because we don't know if that parameter, if it has a value in already, that's obviously going to be used as part of the twist angle so far. If we work out an offset from that point, we don't then want to delete where we'd got to so far. We need the complete offset. So when we do write the script, we're going to be adding in with the existing value as opposed to just replacing the existing value. So let's start out by creating those parameters on our controls, and we're going to create one set of parameters on our attached control and one set of parameters on our detached control, so that we have an offset for when we're blended over to attach, we have another offset when we're blended over to detach, and that means as we blend back and forth, we can blend between those offsets. So I'm going to right click on our shoulder control, hip control parent and edit its parameter interface. I'm going to create two new float parameters, one called twist offset and one called RX offset. Twist offset for our twist angle, RX offset for that control RX parameter. So I'm going to create two new parameters. This is going to be our twist offset. So offset. And then I'm going to create another float, which will be my RX offset. I'm going to select these with shift select, right click and copy, accept. Jump over to our shoulder control master control parent, edit its parameter interface, right click and paste those parameters in so we have those on that control as well. We now need to go ahead and adapt the expressions that are on our shoulder control blend results. So I'll bring up the expression editor on our twist angle, and where we're before simply taking the hip control parent version of the shoulder controls, rotate MY, and multiplying that in when we're blended over to the attach, we want to now take that rotate MY and add on the attached rotate Y offset, so the attached twist offset. Also, when we're blended over to detach on the second line, we want to take into account the rotate Y of our control, the rotate Y of the hip control, and also now the detached twist offset as well. So I'm going to go in here, and when we're blended over to the attached object, we're going to add in the shoulder control underscore hip control parent, and we want to grab that twist offset that's on there. Let's make sure that did take. Indeed it did, fantastic. And again, we're adding that in before we multiply by that blending parameter. Then here we've got our master control parent RY, taking that away from the hip control RY. We then want to add in our detached offset, which exists on the master control parent. So shoulder control, master control parent, and we want the twist offset parameter there. And again, we're adding that in before we are multiplying by that blend parameter. If we accept that and take a look now at what happens when we modify our twist offset, we can see twist angle is set to 0. We can jump in, and if we change our twist offset, we can see that indeed that is affecting our twist calculations, our twist angle there. So we need to do the same for our control rotate X. Again, we need to add in the rotate X offset for our attach before we multiply by that blending parameter. So let's add in shoulder control underscore hip control parent, and we want that RX offset. Fantastic. Again, adding that in before we're multiplying by the blend. And here, where we're taking our controls RX and subtracting the hip controls RX, we want to add in that detach control RX offset as well. So shoulder control underscore master control parent, and we want to grab the RX offset there. So now we are taking into account those offset parameters both for rotate X and for our twist angle. We can demonstrate that again. If we take a look, if we grab our attach, since we're blended to attach, and start increasing that angle, we can see there our control objects being affected by that offset. So now we have that in place, we are going to need to create a couple of parameters on our asset, and that's because we now need to know about that final blend object. We need to know about the blend result, because we know that we have some parameters that are on that null, and we want to reference the values of these to work out where we need to be, where we are currently, and what that offset is going to be. We're also going to add a parameter onto our asset, because later on I want to reuse this system and reuse this asset for our head controls. Now our head controls are going to share the need to have an attach control, detach control, match their positions, orientations, and also have a twist angle parameter. However, our head control is not going to have a control RX parameter involved. So I do want to create a toggle on our dynamic control parenting asset that's going to allow us to say, do we want to blend RX or don't we want to blend RX? So I'm going to bring up the type properties for the asset. Let's jump over to our parameters, and let's go ahead and add a new operator path. And that's going to be our final result object. So that's our final blended result. And I'm going to give that the label of final result object. And this is going to be object null only. I also want to create that toggle parameter, which is going to be the blend RX parameter. It's going to allow us to say, do we want to blend RX or not, so that we can reuse this asset later and uncheck that toggle so we don't blend RX. So I'll accept that. Do want to go and specify for our final result object, that's shoulder control blend result. So let's grab our shoulder control blend result as a relative path. And now that we have that in place, we can now finish off the scripts for our match attach to detach and match detach to attach buttons. So I'm going to bring back up our type properties. And let's go ahead and work on those scripts. So we've already got the matching the control in place. I do want to now bring in that final object. So our final obj is equal to who.pwd.node who.pwd.evalPalm final result obj. So I do want to bring that object in, since we need to reference it later. Before we do any matching, I want to find out first, do we want to be calculating a rotate X offset? And then second, our detach, because we're matching to the detach, so our target, if you will, the target twist angle, and also if we are blending rotate X, then the target rotate X angle as well. So let's go ahead and find out, should we calculate the RX offset? And if so, we want to find, well, always we want to find the detached twist, but we'd also want to find the RX value as well. So we're going to say, should we calculate the RX offset, we can create a parameter called blend RX, or rather a variable called blend RX, and call on who.pwd and eval that blend RX parameter toggle. So if that has a value of 1, yes, we do want to calculate the RX offset. If it doesn't have a value of 1, if it has a value of 0, then no, we don't. It's just easier than referencing who.pwd.evalPalm a number of times in this script. I've set it now in a variable, I can just reference the variable. So to find the detach, twist, and RX values, I need to blend over to the value on our blend that's going to give us the detached controls. That means I need to blend over to a value of 1. Since I'm changing that blend value, I need to store the old blend value just as we did back in character rigging 1 where we were matching FK to IK, so that I can get back to that value. So the old blend value is equal to who.pwd.evalPalm blend, so that I can get back to that value. Again, that parameter does exist on ourselves. And then I'm going to blend ourselves over to detach. So I'm going to say who.pwd.palm blend.get referenced palm .set pending. I'm going to set that to a value of 1, which is going to set us to be detached. Now that we are detached, we can say that our detach twist, this is going to be our target twist, is equal to final obj.eval_palm twist angle. Since we know that the twist angle now on that final object, that blend result null, is going to be whatever the twist angle is when we're set to detach. This is our target, so we're going to say the detached twist is equal to the evaluation of that parameter. We need to do the same for our blends, but only if we are blending RX. So if we're blending RX, then our detach RX is equal to final obj.evalPalm, and that's going to be the control RX parameter that we evaluate there. So we've got those values for the detach. We can now go ahead and match our attach object to detach in terms of position and orientation. So that's our code from before there, still functioning. From this point, we now need to find out what are our new attach twists, and if we're finding them, rotate X values. And that's going to tell us, okay, we know where we need to be. We want to be at our detach twist and detach RX. We know where we are. That's our attach twist and our attach RX. And we need to find an offset to get from where we are to where we need to be. So let's find the new attach twist and RX values. So who.pwd.palm blend. We want to get the referenced parameter, and I want to now blend over to a value of 0 because I want to make sure that we're set to attach. If I'm about to evaluate the twist angle and control RX parameters, I need to be set to attached so that I'm getting the new twist angle and control RX parameters. What are we when we're blended over to attach? So I'm going to set that to attach, and then I'm going to say that the attach twist is equal to final obj.eval_palm twist angle. And again, if we are indeed blending RX, then the attach RX is equal to final obj.eval_palm control RX. So now we have where we need to be in the form of detach twist and detach RX, and where we are currently in the form of attach twist and attach RX. We can now calculate an offset to get from the attached values to the detached values, and that will allow us to get and match those target twist angles. So I'm going to calculate offset to get from attach values to detach values. And what we need to do, we need to say, okay, where do we want to be? We want to be at the detach. Where are we currently? At the attach. So take the attach away from the detach, and that will tell us how to get from the attach to the detach. So our twist offset is equal to detach twist minus attach twist. And if we're blending RX, then our RX offset is equal to detach RX minus attach RX. Now, before we go ahead and set the parameters, for our blend RX, it's as simple now as setting the RX offset parameter on our attach control object to equal whatever it was previously plus this newly calculated RX offset. However, we know that our rotate Y is driving the twist angle, and that our rotate Y is the most important rotation on that control. We set our rotation orders so that if we change a value in rotate Y, it's going to change our twist angle, and it's also going to change our orientation in such a way that we can look for multiples of 360 degrees in that twist angle. And if we take them away from our twist angle and then make up for them, counter them by adding them in to our rotate Y, because of our our rotate order on the controls, because of the way our expressions work, that means we'll get the same twist offset. In terms of we'll get the same twist angle, the final twist angle, but we can have a smaller twist offset and have a more accurate twist in terms of rotate Y, and that's going to be easier for the animator. I'd prefer, if at all possible, to try and store those offsets within the rotational parameters themselves, as opposed to storing them in terms of that offset parameter. So if we can find a multiple of 360, we can take that away from the twist angle, we can add that into our control. We know if we rotate through 360 degrees, we're back to the same orientation that we were in earlier. So I'm going to go ahead and I want to find out if we have the ability to go and take multiples of 360 away. Now before I do that, I want to find the basically new twist angle, the twist offset. We need to add in the currently found twist offset, and that should really be, as we scroll down here, where we got our twist offset. I do want to add that in to the parameter. We can then start taking away multiples of 360 degrees and adding multiples of 360 degrees into our rotate Y. So we had two ways that we could approach this. I was thinking originally that we could take it away from the twist offset, then set that twist offset. What I think I might actually do now is, instead of doing that, I'll go ahead and actually set the twist offset, and then we can go ahead and tweak that later on. So I'm going to say that our attach object dot parameter twist offset get reference parameter set pending, and I'm going to go ahead and set that to our current twist offset in that parameter and add on the new twist offset. We're going to say that attach object dot eval palm twist offset, add on the newly calculated twist offset parameter, and that will give us the new value for setting that new twist offset parameter. We can then go ahead and find out what is our new twist offset, and this makes more sense. You see that we could take multiples of 360 degrees out of the twist offset parameter we just calculated, the value we just calculated, but let's say that this value for whatever reason was 180 degrees, but already existent in our twist offset parameter was 180 degrees. If we add them together, then take away multiples, we'd take away a single multiple of 360 degrees. However, if we were to simply take multiples away from the twist offset, we would result in not having a multiple of 360 degrees we could take away. So whereas earlier I was thinking, we could go ahead and take it away from twist offset, it makes a lot more sense for us to add these together first, work out the new result of that, then take away multiples from that. So you have to forgive me changing my mind on the fly here. This makes a lot more sense in terms of direction. It makes a lot more sense in getting as much of that twist angle taken away and placed into the rotate Y parameter. So now that we've got that, we can work out what is that new twist offset. So the new twist offset is equal to our attach object dot eval palm twist offset. So that's going to give us that new twist offset, and we can now, if possible, we can remove multiples of 360 degrees from our new twist offset, and we can counter them by adding multiples of 360 degrees to our rotate Y. So what I want to do, I want to find out the integer component of our twist offset divided by 360. If I take that twist offset, the new twist offset, if I divide that by 360 degrees, that's going to give me some kind of floating point value. The integer component is going to tell me how many whole multiples of 360 degrees do I have. That then tells me how many do I want to add for the rotate Y and how many do I want to subtract for my twist offset. Now, to do this, I'm going to call on a function that exists inside the Python math module, and that is the modf function. That basically returns two values to us, the fractional part and the integer part. We can then get the integer part from that. Now, to call on that function, I of course need to make sure that I import the math module, the Python math module that will be installed with all Python builds. then we can now go ahead and say get the integer component of new twist offset divided by 360 degrees. So we can say twist revolutions, the full revolutions of that twist are equal to math, that math module dot mod f. We pass in what we want to basically break into fractional and integer, and that's going to be our new twist offset divided by 360. This is going to return the fractional part in index 0. We want the integer part in index 1. Now that we have that, we can take those away, multiples of 360 away from our twist offset. So we can say attach object at palm twist offset dot get referenced palm dot set pending, and we can say new twist offset. So that was our original twist offset, the new twist offset that we want to set in there, but we can now take away multiples of 360 degrees from that. So I'm going to take away 360 degrees times that twist revolutions parameter. And again, we want to take away full revolutions and not partial revolutions. Taking away 360 degrees and adding that into our rotate Y maintains orientation. Taking away a partial revolution will break our orientation. So we can take that away for our twist offset, but then we need to counter that by adding that in to our rotate Y. So we're going to add that into our rotate Y. So set pending. And again, this is going to be our existing rotate Y, so eval palm rotate Y. And I want to add into that 360 degrees times twist revolution. So you can see we're taking that away from our twist offset before we set the new twist offset, and we're adding that in to our rotate Y. We can now go ahead, blend RX, we can go ahead and set the blend RX. Now we can't do the same for blend RX because our rotation orders aren't quite as nice as that, but with our rotate Y we can definitely know that by taking away our rotate Y, because it's the most important rotation, we know that they will counter and balance each other out perfectly. So attach object dot palm rotate X offset, and we want to get the referenced palm and set pending our attach obj dot eval palm RX offset. So we want to take that old rotate X offset, add in the new rotate X offset, and that's going to be the new final complete rotate X offset we need on that parameter. So there's only one thing left to do. We need to restore our old blend value. So we're going to say who.pwd.palm blend.get referenced palm, and I want to set that pending back to the old blend value that we stored earlier. So we can now accept this, and then we can test to see, is this indeed working? Now we set this up on the match attach to detach. That means I need to set something up on our detach control and then try and match it. So I am going to rotate that control through a number of revolutions, which we know is going to give us a very crazy rotation. We can then go ahead, I'm going to give this a very interesting rotate X. Now currently everything's behaving crazily, but we've given it a crazy rotate in Y. Really, this isn't something that your character would be expected to do, but I'm basically testing out in terms of, are we going to match this perfectly, as opposed to, are these controls really behaving in a way that makes sense? I mean, it's the fact that we've gone through such a crazy rotation that your character really would be very much in a situation where you probably wouldn't want him to be right now. So we've got that in place. Let's go ahead and jump to our controls. We can see when we blend, we have a crazy amount of rotations going on. So then let's say match attach to detach, as long as there were no syntactical errors. And indeed there was a syntactical error, and it's on line 45. So let's hunt down line 45. So on line 45, it says 39, 43, 45. It said that the palm object has no attribute get reference palm, and indeed that's because it needs to be get referenced palm. There we go, fantastic. So if I accept that, let's clear, and I'll just move that off to the side in case we need that in a second. Go ahead and grab our attach control. I want to zero all of this back out, so we're back to where we were before we tried testing that. Fantastic. And click on match attach to detach, and our attach control has moved, and if we now blend, look at that. Everything is now working fantastically. If we take a look at our attach control, we have a twist offset, a rotation X offset, and look at our rotate Y. We have gone as close as possible to matching the rotate Y on the existing control, because we've taken multiples of 360 away and added them into our rotate Y, and you'll notice as we blend, nothing is moving in the view, everything is matched perfectly. So I'm going to zero all of these back out. So we can indeed zero out twist offset, rotate X offset, and our rotations. I'm going to zero out our rotations on the detach control. And then I want to go ahead and get this now working for the other button, for the match detach to attach button. So let's bring up our type properties. So I want to copy what we have so far for match attach to detach. I'm going to copy down to where we're matching the controls, Control C. I'm going to do this in stages since some of the script, of course, is already in place. And let's go ahead and paste this in above our existing script. Then where we've got the 3 attach and detach objects, let's paste these up at the top. And that means we don't need the attach object here, we don't need the editable attach, and we don't need the detach. We do want our final object, the attach, editable, detach, and detach. We want all this to remain the same, except for we now need to find the attach, twist, and RX values as opposed to the detach. That means we need to blend over to a value of 0 on our blend so that we're looking at attach, and that means I want to change these variable names rather to be the attach twist and attach RX. Again, we are still referencing our final object there. So now we can go ahead, we match our controls, and after we match our controls, we need the rest of this code. So I'm going to copy all of that. So that's everything after we match those controls, paste that in, and then tweak this because we're now matching detach to attach. So the first thing we need to do, we're now wanting to find out the new detach, twist, and RX values. That means we need to blend over to detach, not attach. And that means that these are going to become our detach twist and detach RX variables. We're then going to calculate the offset to get from, this case we're getting from the detach over to the attach. And that means we need to take our attach and subtract the detach from that. So we're just reversing what we were doing earlier, because now we're trying to get from the other control and back to the attach. Now here where we're setting, or rather where we're trying to set the twist offset, we want to do that on our detach object. And of course we want to set that to whatever our detach object was already set to, plus that new twist offset. And the new twist offset is going to be our detach object .evalPalm, because we want to find out what that value was just set to. So we're going to go ahead and get the new twist offset. We do keep our twist revolutions the same as before. Now where we're setting again our attach object, we want to be setting our detach object. And here we want that again to be our detach object that we're getting the original rotate Y for and then changing. As we jump down here, blend RX, this needs to be our attach RX minus our detach RX. And there where we're setting our attach object, we need to set our detach object. Again, making sure that we take the original value from our detach object, not from our attach object. With that in place, that should be everything we need now for matching detach to attach. So I'm going to accept. And let's put our attach control in a crazy situation. So I'll rotate him all the way around, and then let's start adding crazy amounts of rotate Y into the mix, just so we have something really extreme on our values. Then going to go ahead, and if we blend currently, we can see, yep, indeed, we're getting a huge amount of craziness. We can match our detach to our attach. Everything has matched perfectly. So we now have our controls matching perfectly. We can take a look. Our RX offset is 360. Notice our twist offset is 0 because everything has been put over into the RY. So that's working fantastically for us. Let's zero all of this back out. Make sure we are indeed blended to the attach. So that is going to conclude setting up our shoulder controls. We've taken our shoulder controls, we've got 2 sets of controls, we've looked at how we can drive the spine with those controls, we've looked at how we can create some spine controls that work in conjunction with our shoulder controls, and then we've looked at how we can match both the attach to the detach and the detach back to the attach, so that when the animator is working, they can work with one control and they can instantly switch over to another control. They don't have to worry about trying to position and orient that control and then rotate it through Y to match our spline controls. That would be a very tedious process for them. We want to just provide them with that button. They click the button and instantly they're matched. They can now blend if they want to. They're not forced to. They can work with either control, but they know that the controls exist in the exact same space. So that is going to conclude our shoulder controls. Thanks a lot, everyone.